Linear inequalities have infinite solutions. So they have more than one answer. They have an infinite amount of answers. Their answers go on and on and on and on and on forever. A solution of a linear inequality is an ordered pair, x comma y, that makes the inequality true. So on example 1, it says, is the ordered pair 2, 6 a solution of the inequality y is less than 4x minus 1? So what we're going to do is we're going to take our ordered pair and we're going to plug in for x and for y. So instead of writing y is less than 4x minus 1, I'm going to replace y with 6. And I'm going to replace x with 2. Remember, this is 4 times x, so here I have 4 times 2. And what we're trying to do is we're trying to see if 6 is less than 4 times 2 minus 1. So we're seeing if the left side is less than the right side. To do that, we're going to have to simplify this side over here by using the order of operations. So I'm going to bring down my 6 and my less than symbol. 4 times 2 is 8. 8 minus 1 is 7. So what we need to know is 6 less than 7. Yes, 6 is less than 7. So this ordered pair 2, 6 is a solution of y is less than 4x minus 1. It's not the only solution, but it is one of the solutions. Let's look at example 2. Is the ordered pair -3, -4 a solution of the inequality y is greater than or equal to 1/3 x plus 2? So I'm going to plug in for -3 for x and -4 for y. So I'll have -4 is greater than or equal to 1/3 times -3 plus 2. Well, 1/3 times -3 is -1. -1 plus 2 is +1. So now we need to figure out, is -4 greater than or equal to 1? No, it's not. -4 is smaller than 1. So this point is not a solution to this inequality. We can graph linear inequalities. There are 3 steps to follow to do that, and those 3 steps are right here. We're going to do the same exact steps that we did when we graphed lines. And the only difference now is that our lines can either be solid, like how we drew before, or dashed. And we'll have shading. So if it's greater than or equal to, we'll shade above the line. And if it's less than or equal to, we'll shade below the line. Down here, I give you all of the rules that you need to follow for greater than or equal to, less than or equal to. So if it's greater than, we'll have a dashed line and we'll shade above. If it's less than, then we'll have a dashed line and we'll shade below. If it's greater than or equal to, we'll have a solid line and we'll shade above. And if it's less than or equal to, we'll have a solid line and we'll shade below. So let's try that with this example here. It says graph the inequality y is greater than -2/5 x plus 1. So I'm going to begin with b. In this inequality, b is 1. So that's this point right here. I'm going to move with m. In this problem, m is -2/5. So that means I can go down 2 and to the right 5. So 1, 2, 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4, 5. You want to make sure that you're filling up your whole graph. So the other way that I can go is up 2 and to the left 5. So up 2, 1, 2, 3, 4, 5. Up 2 and to the left 5. My inequality symbol is greater than. So that means that I'm going to have a dashed line. So here is my dashed line. It's still a line, so you still need to make sure that you have your arrows. And then because it's greater than, that means I'm going to shade above the line. Now with your pencil, you're just going to lightly shade. I do not want to see scribbles like this. That's very messy, so we do not want to do that. You could, very neatly draw some lines to indicate your shading, but again, you do want to be nice and neat. I'm going to choose to use a highlighter. Some students like to use colored pencils, whatever works for you. So I'm going to very neatly shade above this line. I'm just going to make that a little bit bigger. And so you want to shade above this line here. So that would be this whole area. So what this shading represents is the solutions. Your solutions are in shaded areas or on solid lines. So if we look at this next question, it says, is the ordered pair 2, 5 a solution of the inequality? Well, 2, 1, 2, 3, 4, 5, that's this point right here. Is this point in the shaded area? Yeah. So because it's in the shaded area, it is a solution. Let's try another example. So on number 1, it says graph y is less than or equal to 1/2 x plus 2. I am going to begin with b. Here b is 2. I'm going to move with m. My slope is 1/2. So that means I can go up 1 and to the right 2. I could also go down 1 and to the left 2. And again, you want to fill up your whole graph. My inequality symbol is less than or equal to, so that means that I'm going to have a solid line. And you still want to have your arrows. Because it's less than, I am going to shade below my line. So that's going to be everything down here. If you need to, go ahead and pause the video. It says, is the point -5, 1 a solution to the inequality? So 1, 2, 3, 4, 5, -5, +1. So remember, solutions are on solid lines and in shaded areas. This point right here is not in the shaded area, nor is it on a solid line. So this is not a solution. On example 2, it says graph y is less than -3. Here I have y and no x. This means that I have a horizontal line. So y equals -3 right here. This is going to be a dashed line because it is not equal to. And I want everything that's less than -3, so I need to shade below. So that's going to be down here. And then we want to know if the point 4, -3, if this is a solution. It is only a solution if it is on a solid line or in the shaded area. This point right here is on a dashed line. Dashed lines are not included. They're like open circles. So dashed lines means it's not a solution. On example 3, it says graph x is greater than or equal to 5. When you have x and no y, that is when you have a vertical line. So x equals 5 right here. This is going to be a solid line. And then we want everything to the right. So when you have a vertical line, you can't shade above or below. So instead you have to shade left or right. Because it's greater than, we're going to shade to the right. And that actually runs off this graph a little bit. So that would be everything over here. The question says, is 10 negative 2 a solution to the inequality? Well, 10 negative 2 would be like over here. That would be in the shaded area, so yes. All right, so let's summarize everything that we've learned today and in the past couple lessons. If I have this symbol right here, we read that as equals. This is the greater than symbol. This next one is greater than or equal to. This next symbol is less than, and then less than or equal to. And then we want to know if each of these symbols are an equation or an inequality. Well, when you have equals, that's an equation. And everything else we have here is an inequality. Oops. And then we want to know if we use a solid or a dashed line. So for an equation, you use a solid line. For greater than, you would use a dashed line. For greater than or equal to, you use a solid line. For less than, you used a dashed line. And for less than or equal to, you will use a solid line. And then it asks us if we shade the graph, and if we do, where? You never shade the graph of an equation, right? An equation is just a line. It doesn't have extra solutions. It just has these solutions that are on the line. With greater than, you shade, so yes, and you'll shade above the line. For greater than or equal to, you shade above the line. For less than, you shade below the line. And for less than or equal to, you also shade below the line. And then we need to figure out what our solutions are. When you have an equation, your solutions are any ordered pair that is on the line. For greater than, your solutions will be any ordered pair in the shaded region. For greater than or equal to, your solutions will be any ordered pair that is on the solid line or in the shaded region. For less than, your solutions will be any ordered pair in the shaded region. And for less than or equal to, that will be any ordered pair on the solid line or in the shaded area. So this chart right here will be very useful to you as you're going through and completing your assignments.